6/9 now. Didn't make any mistakes there, did we? Hello folks, welcome more welcome to you out there for tuning in with us on T and Learn Mathline Summer School this afternoon. It's warm outside, it's hot outside, in fact, it's good old summer, right? And I'm glad you're tuned in to watch us cool off a little bit and have some fun with us doing some math. I'm your host for this afternoon's session of T and Learn Mathline. I'm Ernie Roberts, and this is T and Learn Mathline Summer School. So once again, the good news is we are not going to have a call in today. Well, that can't be bad news. But you know what? What we're going to do instead, we're going to let you sit back, relax. We're going to take some notes maybe, a few problems work together. All about review this summer. So sit back, relax, let's do some math, and let's see what we're doing today. It's all about fraction action. And as part one, we're going to addition of fractions today. This is T and Learn Mathline Summer School. Again, it's kind of review time. Now, let me tell you something. A lot of you think that this is just for the elementary and the middle school kids because it's all about fractions. But you know what? High schoolers, you can stand a review on it. And adults, I have adults tell me, says, we like it when you go back over some of those basic skills and things like that because we've kind of forgotten them. And it's good for us to remember how to do and how to function with them. And sometimes it allows us to be able to help our kids and our grandkids. So thanks for everybody tuning in today. Let's see our first example on T and Learn Mathline Summer School here. Woo, got a good day going here. Add and reduce to lowest terms. We are glad y'all tuned in. Yes, I am on target now. 3/10 plus 3/10 where we start. Now, remember when we're going to add fractions, the whole idea is we've got to have a common denominator, That means they're the same. And in this case, we're set up good to go. In fact, we have a common numerator. That's not required, all right? But we've got to be talking like we're all in tenths, or maybe we're all in fifths, we're all in halves. You cannot add a half and a third as they are. You've got to have something in common to them. So we're going to be talking about those common denominators, and that's what we've got to look out for. Now, another warning, as easy as it seems, let's go ahead and write this first problem down at home. We've got 3/10 plus 3/10. You certainly do not want to add 10 and 10 underneath. That's just simply saying I've got 3 of them, I've got 3 more, add them together, I'm going to get 6 of whatever they are. In this case, it's 6/10. That tenths did not change. It not become something else like 20ths, all right? Now, it does also mention let's reduce to lowest terms. Lowest terms. Now, what's that about, you may ask? Well, that simply means 6/10 is not reduced because we've got numbers that will divide into that evenly. Actually, we got one number. Well, 2. 1 will do it, but 1 doesn't help us any. But the number 2, that will do wonders for us. So we'll divide both that 6 and that 10 by 2. And look what we have. We have 3/5. And that's what we mean by reducing to lowest terms. So we pick up common denominators. We already had those. We were nice. We just simply add what's in the numerator. That's in the top, folks. Some of you forget what numerator and denominator are, but the numerator's in the top half of the fraction. The denominator is the bottom half. And notice what we have there. We add the numerators, leave the denominator alone, and then you come up with 3/5. And that's the story. That's the story of what we've got going today. So we're going to be adding, and if we need to reduce, we'll reduce. If we don't need to reduce, well, life's pretty good. Life's pretty good. Now, another area that we use common denominators in is when we have different fractions and we want to know, well, how do they relate to each other? Which one's larger? Which one's smaller? Which one, maybe they're the same, those kind of things. So let's take a look at our next example here. It says to arrange the fractions in order from the least to the greatest. We've got 2/5. You can go ahead and write these down at home. 2/5, 7/10. I've got a 1/2, leave a little space there. And I've got 3/5 hanging out over here. And what we need to do is get them all into the same denominator. Because it's really hard to say, well, 2/5 and 7/10, maybe I know that, maybe I can tell. 1/2, 3/5, they're all different denominators, so they're all, in my mind, different types of splitting up this whole piece of something. And halves and fifths and tenths don't always, in my mind, come together, and many of yours the same way. So let's put them all into the same denominator format. We start looking. First of all, I notice that 5 will divide into 10 evenly, so that gives me a hint. 10's an option. It may not be our final option, but it certainly is going right now. It's working well. Then I look at 2 and I say, whoa, I'm getting lucky. I've got 2 that divides into 10 evenly. It goes 5 times. That's beginning to tell me 10 is a really good number because I got another 5 out here. If it worked for this 5, it's going to work for the final 5. So 10 is what we're looking for. So we're going to fix all these denominators. We're going to put 10s, 10s, 10s. They're all over the place. There are 4 of them, all right? Each one of these is going to have a 10 in the denominator. Now, the ones that we changed, and those we did. We changed from 5 to 10, 2 to 10, and another 5 to 10. The 10 to 10 didn't change, so we don't worry about it. All right, we're going to leave it alone. But these guys up here that have changed, we've got to change numerators. We've got to change numerators the same way we changed the denominator. You say, well, Ernie, how did we change the denominator? Well, we went from 5 to 10. So we multiplied by 2. So we're going to say 2 times 5. And since we multiplied the 5 by 2, we've got to multiply that 2 also up there on top by the same 2. Now this is that same game plan. 2 over 2 means 1, all right? So we're not changing 2/5 because we multiplied 2/5 times 1, it's still 2/5. But by putting the 2 over 2, we at least change the appearance of this same basic value of 2/5. It's now become 4/10, all right? So that's the game plan. And a lot of times people ask, well, why do we even do that? You always hear the rule. It says, well, whatever you do to the numerator, do it to the denominator. Whatever you do to the denominator, do the numerator, blah, 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 blah. You know, and really what's the rationale behind it? We're not changing the value of that fraction. We're just changing its look to where we can have 10s everywhere, all right? Now, did we change anything here? No, so we just multiplied everything by 1 and we kept 7/10. Life is good. Over here, now this is a different story. We multiplied by 5, didn't we? We want to have to multiply that numerator by 5. Again, see that 5 over 5 is equivalent to 1. So it's just like multiplying by 1. And that's going to give us 5/10, rocking along right in there. And last but not least, well, hey, we multiply by 2 over here. Let's do it right out here on the end here. So we're going to multiply by 2 over 2. Same story, multiplying by 1, like an identity element for multiplication. You know that, right? And that gives us 6. Now, folks, we have some way to compare. Look at this, 4, 7, 5, and 6. In the numerator, it's all about the order. And it looks like 4/10 is leading the way. So what we're going to do, we're going to drop down here, and we're going to start with, what did that correspond to? Well, this one is our first. Let's go ahead and mark it. All right, that's our first term. So we're going to put 2/5 right down there because that's what corresponded to 4/10. Remember, we're going back to our original fractions, all right? What comes in second? Well, number right after 4 is 5. This isn't difficult, is it? Not at all, not at all. So this is our second pick. So 5/10, no, let's go to 1/2, right? Because we want to go back to our reduced fractions when we're listing these. So here comes the order. 2/5, 1/2. Now, where do we go? Got 2 choices left. 6 is obviously smaller than 7, so let's go there. That will become our third position. And we go back to what it was originally. That would be 3/5. And last but not least, our fourth guy right here, 7/10, didn't change, did it? So we're just going to keep 7/10. And that is the order from least, means smallest, up to greatest. Now if they switched you around and said, let's go from greatest to least, then you start at 7/10, come back to 3/5, 1/2, and 2/5. But the instructions, least to greatest. And that's where we go back to. So arranging fractions in order, and by the way, come back to your original fractions when you have a problem like that to do, okay? And that's it. Get to the common denominators. Life is sweet. Life really is sweet. So let's look at some examples. We said we're going to be adding fractions today. That's where we're going. Let's take a look at our next problem here. We've got 1/4 plus 1/2. Get you a chance to write that down at home. And you know, this is really very simply, in many cases, it's not like, think about money here. 1/4 plus $0.50. All right, that's what's going on here. And if you think about your money, that's 25 cents and 50 cents. That gives you 75 cents, which, by the way, is worth 3/4. I'm already telling you, hey, you can do this one mentally, couldn't you? But let's do it with common denominators, and let's show how it works. So what I'm looking at here, I notice that 2 divides into 4 evenly. And in that case, how many times does it go? Well, it goes 2 times. That makes life good, doesn't it? So 4 is going to be our LCD, our least common denominator. Now, some people ask me, Ernie, what if we multiplied 2 times 4 and got 8? Well, you could use 8. You're just going to have to reduce it in the end. So that's why we say reduce to lowest terms in case you might not be using the least common denominator, and sometimes even when you use the least common denominator, those fractions add up to something that still needs to be simplified, all right? Still needs to be simplified. Like our first problem up there, when we had 6/10. We had to simplify it back down. We couldn't have done anything before we added the 3 and 3, but we certainly could when we got 6/10. It happens. So always ask yourself, can I reduce the final answer, all right? Sometimes you can, sometimes you can't. It's pretty straightforward. You either can or can't, right? Two options. Now, let's see what we're going to do with these numbers here. Speaking of options, we have 4 coming into play. So we need to multiply this second fraction by 2 to get to 4, right? And if we multiply the denominator by 2, you got it. Put it to the numerator, same place. So I've got 1 times 2 on top, all right? Let's just look at this, all right? We're doing this, multiplying in both cases here. It's just like a big long fraction going across there. And what are we going to do? Remember, that's multiplying by 1, so it didn't change anything. So I got 1/4 plus, now we got it, 2/4, which gives us 3/4. 3/4, 75 cents. You get the idea of the money. Now that's the key thing. Now I sometimes have students who want to go along and add 1 and 1 and get 2 out of that, and 4 and 2 and get 6 and have 6, which reduces to 1/3. If you were trying to get cents out of that, it'd be like 33 cents. So you added a quarter and a $0.50 and you got 33 cents. Doesn't make sense. That's crazy. And if you think that way, if you look about it and think about your money, this makes sense. Why you have to get a common denominator. It's like, how many quarters? Well, I had 1/4 here, have 2 quarters for a half, add them together, I've got 3 of them. And that's how fractions work. You've got to have, basically, parts have to be added to equal type parts when it's denominator talking, all right? I'm not talking about 1/2 and 1/2 all the time, but if you've got a 1/2 and a 1/4, you've got to have it in terms of those fourths to make it work. That's the trick. That's the story. That's what we're about today, is how to add fractions, all right? So as you look and watch and listen, hopefully some of this will be a review. Hopefully all of it will be a review, but some of you may be watching for the first time, learning fractions, your first, second, or third grade, and wonder, how does that work? Hopefully you'll catch on to what we're doing here, all right? Let's take a look at our next problem. Let's see what we've got going here. It says add and reduce to lowest terms. Notice we've got 3 fractions, and some of you go, oh, you've got 3 fractions. Well, it's all right. We might have 4 or 5 to add by the end of it. Only kidding, only kidding. We're going to work with 3 fractions on this one here, and I want you to notice some things already starting in place there. You've got 2 9s there in the denominators. Go ahead and write that problem down at home. 2 9s plus 4 9s, and while we're at it, we're going to add 1/3. 3 fractions. Now, obviously, some of you say, well, could we go ahead and add 2 9s and 4 9s? Why not? You could. It would be 6 9s, all right? 6 9s. And some of you say, 6 9s are both divisible by 3. We can make something happen there. You certainly could. You could also decide, let's go ahead and add 1/3, but let's make it into 9ths also. All right, so let's do it that way, because I think a lot of you are probably already working it in that manner. But again, I like to point out different ways on this show that you can work the same problem, and using the correct rules, you can get the same answer, and they're legit. Okay, it's more than one way to work this one. But sometimes there's not but just one way to work a problem, but this one's got a couple of options. Let's see, we're going to make 9s happen, right? Because we want a common denominator situation. So got to multiply by 3, and don't forget your numerator. Multiply it by 3 up there, and that's going to give us the 3 9ths, all right? Again, remember, when we multiply by 3 over 3, that's like multiplying by 1. We've not changed the, quote, 1/3, but we've now made it into 3 9ths, which is the same equivalent fraction as 1/3. That's the catch. Now, add them together. By goodness, not the 9s. Leave the 9s alone. They're on the bottom there. They're just adding 2, 4, and then 3 more, all right? Which gives us 9. Oh, my goodness, we got 9 out of 9. We got the whole piece back together. We got a whole. These 3 fractions added to give us one whole, whatever piece we picked them out from, right? So, what's 9 over 9? It's going to give us a whole, which is 1. Remember, over 9, when we read that, and that's very much used there, but 9 over 9 simply means 9 divided by 9. And we know 9 divides into 9 one time with nothing, absolutely nothing left over. So that's your simplified reducing to lowest terms. Back to that 1. And sometimes, will 1 over 1 be okay? 1 over 1 is fine, but it still equals 1. Equals 1. Now, let's take and add some more fractions here. Let's take a look at our next problem here. Going to 4ths and 8ths. And again, always start off by asking yourself, can I divide one of these, the smaller denominator, into the larger number, go evenly, all right, with denominators, all right? So let's take a look at it. 1/8 plus your 3/4 plus 3/8. And again, I notice 3/8 and 1/8, and a lot of you do too, and notice, hey, that's, you got it, 4/8, which would reduce to 1/2, and you can work it from that standpoint. I'm going to go ahead and work it with what we have here with the 4s and the 8s, and we'll probably need to reduce in the end, all right? So if we do, we will do it, all right? Let's take a look at it. Obviously, as I said earlier, 4 divides into 8 evenly, so that tells me go with 8. Go with the number 8 right there. We want an 8 in each position. And obviously, I don't need to change the 1. I don't need to change that 3, but I do need to change that middle 3, the one that is in the 3/4. So to get there, we multiply by 2. And if we do the denominator, we've got to do the numerator, right? Because it's simply like multiplying by 1. And here we go, 6/8. Ready to add? I'm ready to add. Are all of you ready to add? I'm ready to add. We get 10 of those, 10 over 8. Now, let's go a little bit here. A couple of places we can go at this point. We can go ahead and divide 8 into 10. It goes in there one time. I know that because there's an improper fraction. We're going to make a mixed number out of it. But I see something else that we can do. I like the idea that we can make these numbers smaller before we divide. And for many of you, that's a sigh of relief because you don't like to have really big numbers when you're trying to divide things in your head or even on paper, all right? So let's go ahead and make that 5/4, 5 divided by 4. And some of you say, that's like $1.25, or that's like 1 25/100, or 1.25 as a decimal, yes. But we started as fractions. We're going to keep as fractions because we want to reduce to lowest terms. Well, this is lowest terms. And in Algebra 1 and on down the road in a higher level math, you can leave it there. I personally like a mixed number because it tells me a little more what's going on. 5/4 is interesting, but 1 1/4, I can picture that. Picture 1 and a little bit extra, all right? So, and by the way, that's what the answer is because 4 divides into 5 goes one time, and you have 1 left over that mixes in with your 1 1/4. So moving from an improper fraction to a mixed number, it's not hard. It's just running the division with, guess what? How many times it go into and what's the remainder? Put the remainder over that denominator and you're in business. So 1 1/4, you got it, all right? That's what we're doing here, today, all right? Good stuff with adding fractions here in summer school nonetheless. Whew, you think summer's good? I know it is. Let's take a look at our next problem here, what we got. All of a sudden, boy, look at those 3 denominators. I gave you some doozies, didn't I? 1/3, 3/4, whew, there's 5/6. And you say, Ernie, you left a lot of space there, didn't you? Because we don't have a number that all 3 of these numbers divide to that's sitting there looking at us. Now, there is a number. There's always a common denominator. And there's always a least common denominator for 3 denominators. Sometimes we have to look for it, all right? This one we're saying, well, 3 goes into 6, and that's a good start. But let's go back even a better start, I think. Let's look at 3 and 4. Now, the reason I said something about 3 and 6, whatever we find for 3 and 4, that 6 should work with also. Okay, that 6 should work also. And so forget about 5/6 just a second, all right? Let's play with, get you a little dizzy out there? 3 and 4, what do we do with that? If you'll multiply those 2 numbers together, because they're side by side, they're right next to each other, it will give you the least common denominator for 3 and 4. And 3 times 4, of course, is 12. Yes, 3 divides in there evenly, goes 4 times. Duh. 4 divides into 12, 3 times. That's why we multiply them, because we knew we get a common denominator. In this case, since they're right next to each other, we know we'll get a least common denominator. Now the question is, will this number 6 down here, with a 6 denominator, will it divide into 12 evenly? Well, it does. It goes in there 2 times. So that's really good news. We have a least common denominator of 12. And some of you are getting panicky going like, oh my goodness, I thought it was going to be real big. Well, 12's bigger than 8, bigger than 4, which we've had so far, but it's not a real nightmare, all right? It's not that tough. But here's what we've got to do. We've got to remember, what did we multiply 3 by to get to 12? Now, let's start doing that mentally. I know I've been writing it down for you here over and over, but let's start getting some things that we can do in our head, because it gets easier for us. As we learn the process, it's easier to start thinking, all right, 3 times what number gives us 12? Brain's going, right? It goes 4 times. 4 times 1 catches us with 4. So in other words, we took 1/3 and renamed it as 4/12. All right? It's the same quantity, same part of a whole there. How about it? 3/4. I need to multiply both by 3, don't I? 3 times 4 gives us 12. How about it? 3 times 3 gives us the 9 up there. Looking good. We already know 6 goes in there 2 times. And 2 times 5 catches us with 10. At this point, we have our sweet numerators to add together. I count 23, and do not, again, don't add those 12s together. It's not 36 down there. It's just 12. And we picked up an improper fraction. For those of you and your teacher says, that's okay, leave it improper. But I like to mix them up. So it goes in there 1 time again. 12 goes in there 1 time, and we've got actually 11 left over. So now we take that 11 and we put it over our 12, because that's what was in the denominator, and that's how we split it up, all right? 23/12 becomes 1 full piece and 11 left over, 11/12, all right? So when you run the division on that, that's what you got going. So there you have it, a little bit of least common denominator business, 3 fractions. Practice. Let's practice one real quick here. Let's see what we've got here. This one says 1/2. We know 1/2 can take a lot of looks, all right? It's a very, very flexible fraction. It's a benchmark fraction, we call it. How about it? 4/9. Go ahead and write these down at home. And last but not least, I've got 5/6. A little bit intimidating when I think about those two. But I also notice that if I look at 2, which is, by the way, a prime number, which usually means you're going to, unless you've got a number this will divide into evenly, you're going to be able to multiply these 2 and get your least common denominator, at least for those 2 fractions. Now the 6 maybe will help out. We hope it does. But let's multiply it. 2 times 9 gets us 18. And now think about that 6. Woohoo! The 6 divides into 18 evenly. So guess where we're going? We're going to use 18. We're happy. I'm happy. Are you all happy? I hope everybody's happy. Summertime, Mathline. Happy times. Yes, okay. Now, get to the math, Ernie. Get to the math. You got an 18 working all the way down there. Thank goodness we don't have to add all those 18s together. Remember, we're going to bring them along for the ride. But we do need to change some numerators here. Don't add 1, 4, and 5 at this point, all right? You got to change them. Got to change them. In fact, everything's changing, all right? So, starting. Multiply this 2 by 9. That's how you got to the 18, right? So you're going to put 9 over 18 because that's what 1/2 works out to be. Let's take a look at our next one here. We multiplied by 2. That means we need to double the 4 also, or multiply by 2. That's going to give us 8 over 18. Last but not least, how about it? Take 6 into the 18, goes 3 times. 3 times 5 gives us 15. Wow. Did we do them right? Let's make sure, because those are big numbers. We don't want to miss add, right? Let's see what happened. Let's see what we got going here. I see. 9/18. That looks good, right? Everybody good? Cha-ching, cha-ching. Always good to check your fractions and your multiplications. Here we doubled everything. 8. Looks good. And last but not least, we've got 15. Now, we're going to add these 3 numerators together. Remember, it's all over 18. That's not changing, all right? It's not going to change. But be careful in your addition. Now, 9 and 8 gives us 17. Add 17 and 15. Believe it's going to be 32. And some people get real excited because they say, oh, 32 over 8. That goes 2 times, doesn't it? No, 16 goes into 32 2 times. We're off just a little bit here, all right? So it goes in there only 1 time. And it looks like we've got 14 left over. Now, this is one of those where we get to reduce, all right? Once again, it says reduce to the lowest terms. Lowest terms, right here we go. We got this, we've got this 14 over 18, which would give us, how about it, folks? What do you think? You're out there thinking? Divide by 2, they're both even, right? So 1 7/9. Now, I'm going to go back just a second here. What if I had gone ahead and divided the 32 and 18 by 2? Which I did a minute earlier. Remember I said I don't like those big numbers, and I want to go ahead and do the big numbers because some of you probably were going ahead and tacking it, all right? But we could have made that divide by 2 moment right there. And you know what that would give us? It would give us 16 over 9. And that's a lot easier to come up with 1 7/9. So point being, both ways get you to the same destination. All of these were equivalent fractions. Two are mixed numbers. One is just a good old fraction with an improper fraction, but they're all ways to represent the same final reduced value there. So when we add, common denominators first, change your numerators, then do your adding, then check for that reducing moment at the end. So a little bit of review today on adding fractions. We're going to do other fraction operations. We're going to be subtracting, we're going to be multiplying, we're going to be dividing. This is all about summer school, remedial time, but that way, my friends, the whole idea of what we're doing on T and Learn Mathline is to help you be ready for next fall when you go back to school, all right? Excuse me, next August. Fall doesn't come until September, but we do go back to school in August. So anyway, thank you for tuning in out there this afternoon. We hope you've had a good time, learned a few things, hopefully. We're going to be talking fractions the rest of this week and probably a lot of this summer. Thanks for tuning in, and you know what? We're going to see you again next time.